Good? Okay. All right, 144, we did the surface area. No, we did the volume of a cone yet before. Now we're doing the, wait, did we use surface area of a cone? No, we did volume of a pyramid and of a cone. And we're building on that and finding the volume of a cone a little bit differently here. Oh, we're doing volume of a cone. Yesterday we did volume of a pyramid, now we're doing volume of a cone. Sorry about that. So, volume of a cone, show your work. It says find the exact volume, use 3.14 for an approximation for pi. Round your answer to the nearest tenth. Formula for area of a cone. Volume equals 1/3 big VH. Does it look familiar? Yeah, because it's also the formula for the volume of a what?
Square triangle thing. It's not.
Cylinder would be if you take this off.
Pyramid.
Pyramid, yes. It's the same thing as the formula for the area of a pyramid, but the only thing is for a cone, and I would say, I might even write in my notes, volume of a cone equals, and then say this. The only thing is that for a cone, the base is not a square or a rectangle, the base is it's a cone.
Oh, it's a circle.
Yeah, it's a circle. So when you have 1/3 big B, area of a circle is what? What's the formula for area of a circle?
Radius times
Pi
times radius squared.
times radius squared. So if you want the exact formula for the area of a cone that you want to use, the one I would be putting in my notes if I was you is 1/3 pi r squared times height. Circle it, star it, put little highlights by it, whatever you want, but that's what you gotta know for the formula for the area of a cone. 3, 2, 1, okay. Then going on to the first one, it's got that example there. Remember that when we read these, the first thing we want to do is write down what we already know. Then write down the formula, then fill in what we know. So here it says the height is on bottom page 144. Height is 7, radius is 3. Height is 7, radius is 3, and this is centimeters, just so that we remember to put that back on at the end. Then we put in the formula. Volume of a cone is, what did we just say? Yep. And then we put in what we know. We know 1/3 is 1/3. It said to use 3.14, I believe. Yep, it says use 3.14. Wait. Yep.
Okay.
Use 3.14. And then the radius here we know is 3, and the height is 7. And we don't know what the volume is, but we can fill in everything else, yeah?
So the volume is 1/3. No. I need you to go over that again.
What do you mean go over it again?
Not like the whole thing, just like what's the for volume? What's the steps?
What's the steps?
I can't read that.
Volume equals 1/3 pi r squared h. My r not good enough for you?
No, it's not that I like can't read it because it's like sloppy. It's just like
You don't understand it?
Yeah.
Well, think about it. This is a cone. Think about it in terms of what a cylinder is. So think of a cone inside of a cylinder. So a cylinder is the area of the base, pi r squared, times the height, right? Basically what this says is that any cone at all, doesn't matter what kind of cone it is, doesn't matter what the proportions are, if you were to have a cylinder with the same dimensions, the cone is automatically 1/3 of whatever that, the volume of the cone is automatically 1/3 of whatever that cylinder is. Always, you can check it, no matter what it is, it's always
So
gonna be
why don't
1/3.
Why don't you just do the same steps for cone and then times 3 at the end?
You mean divide by 3 at the end?
Yeah.
Yeah, you would do the same thing. Yeah, that is what we're doing actually. I mean, well, it's not exactly what we're doing here. So we have to simplify here. What can we simplify here? Think. You want to be thinking to yourself, what do I have to do so that I do not have to use my calculator? You should have to use your calculator for one thing in this, and one thing only. Think about in terms of your numbers. You have this. You have this. The only thing you should have to do is multiplying something times 3.14. You can simplify 1/3, 3 squared, and 7. Let's rearrange them. 1/3 into this. Simplify. 3 squared becomes 9 times 7. I'm going to put each of these over 1 times 3.14. What can I do with these?
You can,
Yep. Cancel it out. 3 times 7 is 21. Now, here in your book, they do have the example. Instead of putting 3.14, they put 21 pi. This is considered the exact, quote unquote, the exact answer, because pi is an irrational number. Remember, like if you put in your calculator, even if there is actually in your calculator, there's like a blue pi that you can find that you can put in it, what pi exactly is. Now for this problem, it says use the approximation 3.14, so it doesn't want you to use the exact one. When you're in high school, a lot more often they'll have you use the exactly what pi is. But here, you want 21 times pi. If your book and some of your assignments will ask for this, if it asks for the exactly what 21 pi, what the exact answer is, exact answer just means, hey, we want you to put it in terms of pi, not in terms of what it exactly is. You might want to make a note of that because a lot of students get confused about that on a regular basis. So if they say, hey, I want the exact answer and I want the round the answer to the nearest tenth, then you would say, hey, 21 pi is one answer. Well, you would put centimeters cubed because that's the volume. And then here is when I'm okay with you using the calculator, and here should be the only step. I should see all the work for the rest of the stuff in your steps except for this. 21, if you want to do 21 times 3.14 in your calculator, go for it. It says 65, oh, I just wrote out 21 again. 65 point, and it says round to the nearest tenth. It is always going to say to round to the nearest tenth. So 65.94 is what your calculators say. You just round 65.9 centimeters cubed. Now, this one, I believe the instructions said, use 3.14 as approximation, round your answer to the nearest tenth. Again, if they ask for the exact, you would put the first answer. If they say use 3.14 round to the tenth, you would put that second answer. Anyone still want this up here right now? Okay. Let's go guide practice number 5. Let's use the party hat, yeah?
I just want to point out that I'm pretty sure I found the original.
That's great, you can put it on my desk. I lied, we're gonna do guide practice number 6.
Well, no, there's a new one still.
On my desk. Guide practice number 6, it says, so first step, put what you know. They tell you what the diameter is, and they tell you what the height is. Formula 1/3 pi r squared h. Fill in what you know. I'm gonna give you guys two minutes to work on that. Remember, and this one it says it wants the answer. Use 3.14 round to the nearest tenth, so it doesn't want the exact answer in terms of pi.
Which kind of practice is this?
Huh?
Which kind of practice is this?
Number 6.
have the square root of 98?
Maybe because it wants to have an exact answer. Just like, I don't know if you were paying attention to what I was saying, that sometimes the answer to volume is in terms of pi, because pi is an irrational number. Same thing, square root of 98 is an irrational number. So that might be why they're learning it. Is this your work?
Yeah.
Oh, so you had this, and then you just simplify that. I honestly, I'm okay with that. You're on seniors 10, right?
Yeah.
Yeah, I would just keep on doing that for the answers. It doesn't matter to me which one over one, even if it gets to the test or whatever, you're gonna be able to see whether or not you had it right or not. Okay, let's go through it. Diameter was what? 9.
Yeah.
Okay, height is,
14.
okay, do we know the volume?
No.
1/3 we have. Do we know what pi is?
3.4.
Radius?
3.5.
What?
3.5.
9 divided by 2 is not 3.5. That would be 7 divided by 2.
It's 4.5.
Yeah, so 4.5 here. Now here is one thing that you can use that can actually help you here, so you don't have to do more work. Is there a different way of saying instead of, do you have to put it as a decimal?
No.
Okay, now you're looking at me like you think I'm nuts, which it does sound this way at first, but think if the whole goal is for me to, I'm gonna put this as 14. If the whole goal is for me to say how can I cancel out as many numbers as possible and not using the calculator, that's actually more helpful for me to say, hey, this is 9 over 2, and whatever this is, I'm squaring it. Because here I can cancel stuff out more. Just bear with me. So I would keep on going on it. 1/3. I'm going to put this as 9 times 9 over 2 times 2 times 14 times 3.14. See how this is the same thing? We did 9 squared. That means that basically means that we can say, hey, 9 squared, 9 squared. 9 over 2 times 9 over 2, 4.5 times 4.5. That's the same thing here. Is there anything we can cancel out? 9 and 3. This becomes 1, this becomes 3. Anything else? There's one more thing.
Yeah, 3 and 9, right?
3 and 9 are both on the top, so you can't do that. You said? The 14 and the 2. This becomes 7. This becomes 1. 3 times 9 times 7. Now, this is getting to the point, do you think I may expect you to do all this just without any calculator? No. So I do want to see, hey, you're trying to make it work some more. But at this point, the only thing you have on the bottom is the 2. 3 times 7 is 21 times 9. It doesn't matter which way you break it. You're probably going to have to use a calculator. 3 times 7. So 21 times 9, and whatever it is, times 3.14. So this is one of the ones where I'm okay with using the calculator beforehand, but I do want to at least see, like, hey, are we trying to figure out some way we can cancel some things out or not? So 21 times 9, you guys got what that is?
Nope.
Well, can you work it out on your calculator real quick? What? 189? Oh yeah, I actually did know that. Divided by 2 times 3.14. If I keep on going with that, 189 divided by 2 is what?
94.5.
Times 3.14 is
296.73.
But if we round that to the nearest tenth, it becomes,
296.11.
and this is the formula that centimeters cubed. one other thing it does say, it says, find the exact volume of the container. That second line says the diagram, first line says diagram shows a cone-shaped container. Second line, find the exact volume of the container. So that right here, that's where you would have pulled this and said 94.5 pi centimeters cubed. So you would have two answers for this. And again, you're gonna have to pay attention. On the assignment, it will say, find the exact volume, that's in terms of pi, and it will say, hey, use 3.14 round to the nearest tenth. That's when you have this. So you should have two answers. One is 94.5 pi centimeters cubed. The other one is 296.7 centimeters cubed. Okay, this next one, I'm just gonna work through this last one myself, and then I'm gonna let you guys go on some homework afterwards, because I don't think you need the extra stuff from me. But bottom of page 145, safety cone has a height of 30 inches, height equals 30, and a volume of 2009.6, volume equals 2009.6. What is the radius of the safety cone, excluding the base? So that means like the square around the bottom of the safety cone. What's the square of that? Use 3.14. One other thing you notice about this, we know this answer is actually not going to be fully accurate. Based on the picture, how do you know that the answer is not going to be fully accurate? Yeah?
Because A is hollow inside and B doesn't come to an exact point.
Yeah, the hollow inside thing doesn't matter as much, because you might be trying to figure out how much stuff can we put inside it. But yeah, the bigger point is it doesn't come to an exact point. A perfect actual cone would come to one like that. The volume for this would actually be a much, much wackier volume to try to figure out. You're welcome, they're going easy on you here. So I know these, I then write volume equals 1/3 pi r squared h. I know this is 2009.6. I'm going to put inches here so that I remember it at the end. Times 1/3 times 3.14. Now, did this one say that I need to find it out in terms of pi? No, and it's not going to, unless, the only way it's going to say in terms of pi is if you're trying to find the what? The volume. Because the volume would actually be in terms of pi. Anything else, it's not going to be in terms of pi. What are they also going to tell you to find? The circumference around the circle? No, that would be in terms of pi. But you're not going to do all the other stuff in terms of pi, unless it's the volume. And then the height, they said, is 30 inches. What right away should stand out to us that the first step is?
30 and the 1 over 3.
Yep, so this turns into 1, this turns into
10.
10. Now we have 10 times 3.14 is 2009.6. What did I miss here? I forgot something. Look at the formula. From here to here, I lost something.
Not R squared.
I forgot r squared. Why is that important to not forget?
It's one of the
Part of the
steps.
formula?
It's it's part of the formula. It's literally what we're looking for. We're trying to find the radius here. So r squared, I'm just going to add that back in there. R squared. So here, I can actually just take it, and 10 times that becomes 31.4. So now I have 31.4 times r squared. I divide by 31.4. This is a calculator. Can you guys let me know what it was?
There's probably a calculator.
64.
64 even?
Yeah.
Okay, so what's the radius?
64 centimeters. Wait, was it centimeters?
The r squared is 64, so what is the radius?
Oh, wait.
How do you find it? How do you undo squaring something? What's the opposite of squaring?
I forgot what it's called.
Square,
Root.
square root. This is the big thing that you're gonna need to put in your notes. I'm not gonna make you guys do the extra problems on this, as long as you put this thing in your note. The opposite of squaring is taking the square root. When you have radius squared, which that's why they went over this part, because they wanted to remind you, hey, you gotta make sure I know how to do square root. R squared, square root, square root of 64 is, you don't need your calculator for this, what times what is 64?
8?
Yeah, 8. No,
8, I said
7 is the square root of
7.
49, nice try.
8, 9.
8, and I believe it's inches for this one. That's what you need to know. Any other questions? Okay, can you pause that?